Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I want to go over a couple of examples of exponential as well as logarithmic equations. But something that maybe I failed to mention last time or the last two sessions, which is extremely important, is that no matter what you use a power that is negative. So for example, if I say x, so not x, like pick a number, 5 to the negative 100. The answer can never be negative. In fact, it cannot even be zero unless this number is infinity. 5 to the negative infinity is zero. But this is a very small number, very close to zero. That is basically 1 divided by 5 to the 100. So you multiply 5 by itself 100 times, you get a humongous number, and then you take the reciprocal of that. So it's very close to zero, but never negative. Never negative, unless you use complex numbers, which you haven't covered and you won't cover for a while. On the other hand, we cannot take the natural log of a negative number. Again, if we are dealing with real numbers, the numbers that we use, right, from negative infinity up to positive infinity, but not complex or imaginary numbers. Now you can take the natural log of a negative number. But the natural log of x has to be greater than zero. Natural log of zero is negative infinity. You cannot even get zero. So these are very important because sometimes you solve an equation of a natural log and you get, it's a quadratic equation, so you end up with two values of x. If one of them would make the quantity between parentheses negative, you have to exclude it. I don't think the example, I just picked some examples. I don't know if we will encounter this case or not, but when you solve logarithmic equations, your job doesn't end by finding the value of the variable or the values of the variable. You have to go back and check each one of them and make sure that the quantity between parentheses for a natural log is positive. Okay, so let's look at some examples. I think I made like, oh, here's the page. Okay, so now we start with these exponential functions. 15 to the 2x equals 250. And because I have a power, I need to take the log. It doesn't matter if you take the log or the natural log, it's the same. They're not the same, but I mean, the answer would be the same. It doesn't matter. So I can say log or natural log, if you want, of 15 to the 2x equals log of 250. So I took the log of both sides. Okay. Now, remember we said log of a to the power of b equals b times the log of a. Now, unfortunately, 250 is not a power of 15. If that was 225, it would have been log 15 square, which can be written as 2 log 15. So the 2 and the 2 cancel, the log 15 and log 15 cancel, and you get x equals 1. It's so easy. But unfortunately, it's not. So now I treat it as if I was treating an algebraic equation. I have to divide both sides by 2 log 15 because I need to solve for x. 2 log 15, 2 log 15. Now, the 2 and the 2 cancel, the log 15 and the log 15 cancel, and here's the answer for x. So now I can use my calculator And say log 250 or natural log of 250, it's the same thing, but if you use natural log here, you use natural log there. If you use log here, you use log there. Divided by, and between parentheses, I'm going to say 2 log of 15, close them both, and the answer is roughly 1.02. So x equals 1.019 or 1.02 to 2 decimal places. Okay, we knew that 15 square is 225, right? Did I show you how to square a number that ends with 5? If you don't, it's in the playlist. So 15 square is 225. So to get it 250, you need to increase the x a little bit. It's not 1, right? So that's why it's very close to 1. So it makes sense. Sometimes when you can check the answer, if I end up say with 12, I say no, that doesn't make sense. 15 square is already 225. We are very close to 250, so it would be slightly higher than 1. Okay, so always check your answer, see if it makes sense. Second problem, 3 to the negative 2x plus 2 equals 81. I'm waiting to see. I want you to think a little bit. The first thing you always have to do, like we did here, is to see, is the 81 a power of 3? Of course it is. It's 3 to the 4th. It's 9 times 9. And the 9 is 3 times 3. So you get 3 times 3 is 9, times 3 is 27, times 3 is 81. So the easiest way, I can do it this way, by the way. I can solve it the same exact way. However, it's easier to say equals 3 to the 4th. If 3 to this equals 3 to that, then this equals that. However, just to show your work, I don't care, but sometimes in a test or something, the teacher wants to know that you didn't really copy the answer from someone else. So it's better to say, I'm going to take the log of both sides, okay? Log, and it doesn't have to be to the base 3. You can take log of 3 raised to the power of negative 2x plus 2. In fact, let's make it log to the base 3 because it's better, okay? It's easier. I mean, not easier, it's really the same, but the reason I want you to do that is to show you something. We said that the exponent and the log cancel each other. That's why, do you remember last time when we said log a to the power of b equals b log a? Here, log to the base 3 of 3 is 1. So the right-hand side is 4 times log to the base 3 of 3, and the left-hand side is negative 2x plus 2 times log 3 to the base 3. Even if I didn't, what I'm saying is, even if I leave it without the base 3, that would be log of 3 and that would be log of 3, so I can divide both sides by log 3 and they cancel each other. But log 3 to the base 3 is 1. We know that. And this is 1. So you can see that the answer is readily available to you. You see what I'm saying? You don't have to say the 3. I can say log 3 and log 3 and then divide both sides by log 3. So I get the same result. But I wanted to show you that if you take the log of a power of the same base, that becomes 1. The log of 3 to the base of base 3 is 1, because 3 to the first power equals 3. So log to the base 3 of 3, I say 3 to which power gives me 3? Of course, 1. Okay? So this is just to remind you of what we did before when we say log to the base b of b is 1. Makes sense, right? B to the first power is b. And from here, you get negative 2x plus 2 equals 4. You can multiply the equation by negative 1, and you get 2x minus 2 is negative 4. Oops. Then you can add 2 to both sides. So you get 2x equals negative 2. And then you divide by 2 both sides and get x equals negative 1. You can always check. And in fact, you have to check. I know that doesn't mean that the negative 1 doesn't work. Of course, you can raise to any power, positive or negative. It doesn't matter. I want to see if I will get 81 or not. In fact, you don't need a calculator, because if x is negative 1, then negative 2 times negative 1 is positive 2. Positive 2 plus 2 is 4. 3 to the 4. Yes, 3 to the 4. So you don't even need to check it with a calculator. Here, you may check it. I didn't delete it, right? So if I say 15 raised to the power, and then between parentheses, I say 2 times that, I should expect to get very close to 250. Not exactly because of the approximation of the calculator. You get 250.0003 at the end. Okay? So it's always a good habit to check your answer. Now let's move to logarithmic equations. This equation these are to the base 10, because I don't have a base, and it's telling me log 4 plus 3 log x equals 10. So how do I solve that? The first thing you have to understand is this. I have the right-hand side. I want to make it left-hand side. I have 3 log x that I will have to write as log x to the third. And this is log 4, and this is 10. Wait. This is x cubed, right? So log 4 plus log x cubed, didn't we say last time it's log 4x cubed? You multiply them. If they are added two logs, you can combine them into a single log by multiplying these numbers. So this is log of x cubed. The 3 became the exponent. And then 4 times x cubed is 4x cubed equals 10. Okay? So what do you do after that? I already have a 10 here. I have a log, I'm sorry, log to the base 10. So this is telling you that 10 raised to the power of 10 equals 4x cubed. 3 raised to the first power equals 3. Base raised to the right-hand side equals the number. That is a huge number. We're just making some numbers. So this can be rewritten as 10 to the 10, which is a humongous number, equals 4x cubed. So x cubed equals 10 to the 10. That was a bad choice. I should have divided by 4. And then x is the cube root of this whole thing, which would be huge. Like in the thousands, right? Okay, so what is 10 to the 10 divided by 4, and then raise this to the power of 1/3. I don't need the parentheses, but just to make it easy. Cube root is 1/3, power of 1/3, right? I told you in the thousands. So here, x equals 1357.2. Again, it doesn't matter. You can make any numbers. It's just, these are not like real life problems. These are just some numbers so that you get used to solving these problems. Okay, I'm gonna wait and let you think about this for a second. And then we see how we simplify that. It looks too complicated. Okay, like we did last time, the multiplier becomes exponent. So I will write this as log of 2 times 2 square. And there is a 4/3 here. Minus 1/3 log to the base 2 of x equals 2 for now. Notice that this 2 comes down as a multiplier, so that would be 8/3 log to the base 2 of 2 minus 1/3 log to the base 2 of x equals 2. What did we say log a number that is exactly equal to the base is? This thing is 1. 2 to the first power is 2, right? So this is 1. After that, I can subtract 8/3 from both sides. So these cancel, and you get negative 1/3 log to the base 2 of x equals, and I say 2 minus 8/3 is negative 2/3, because 2 is 6/3. So 6/3 minus 8/3 is negative 2/3. Then I will have to multiply both sides by negative 3. So negative 3 times negative 1/3 is 1. So these cancel. And negative 3 and the negative would cancel. So I get log to the base 2 of x equals 2, meaning x equals 2 squared equals 4. Let's look at that. If x is 2, if x is 4, okay? Then I would have 4/3 log 2 of 4 minus 1/3 log 2 of 4, which is the same thing, meaning 4/3 minus 1/3 is 3/3 or 1. So I get log to the base 2 of 4. Well, that's 2. 2 squared is 4. So you can check that solution very easily. It's confusing, but that's how it works. Someone else could have said, I don't like that. I really don't. So what should I do if I want to solve in a different way? Is there a different way to do it? Well, let's see. Let's get back. Where is the paper we had when I was telling you there is no negative? Yeah, here it is. See, remember when we had two quantities subtracted, I can say this is 4/3 log to the base 2 of, I'm sorry, first we say log to the base 2 of, because these are subtracted, I'm going to say 4/3 log, I'm sorry, what am I doing? 4/3 times, so times 4 again. In fact, it's easier to say log to the base 2 of 4 raised to the 4/3 power divided by 4 raised to the 1/3 power. That's what I meant to say. In fact, this was x, right? But I'm saying I'm checking the answer. So 4, I took the log 2 out. So this becomes log 2 of 4 raised to the 4/3 power. And this is minus, so it becomes division. And this is 4 raised to the 1/3. 4 to the 4/3 divided by 4 to the 1/3. We learned that from exponents. That becomes log to the base 2 of 4 to the 4/3 minus 1/3. But 4/3 minus 1/3 is 3/3 or 1. So this is log to the base 2 of 4, which is 2. I know it's a long way, but I wanted to show you that there are multiple ways you can check your answer, but of course the answer was easy. If you submit that in your calculator, and instead of that, you say log 4 divided by log 2, because we said we don't have log to the base 2 in a calculator. You can either use the log or the natural log. Okay, I hope I didn't confuse you. But this problem was easy. Now the last one. In the last problem, we are having log to the base 4 of x squared plus 6 to the x, 6x equals 2. How do I get rid of the log? One way to do it is to say, well, we already learned that log to the base b of a equals c. It means b to the c equals a. But why? Why do I have this law? I can simply say 4 squared equals whatever is here. But to see why, remember we said the log and the exponent are inverse of each other. So if I take 4 to this power, it should be 4 to that power, right? I have the log to the base 4. So I took the inverse function, which is the exponent. I'm going to take this 4 and raise it to the power of log 4. Well, these two cancel each other because they are inverse functions. Again, you don't need to do that. As I said, you can say base raised to the power of the right-hand side equals this quantity. But I'm showing you here that these two guys really cancel each other. So you get x squared plus 6x equals 4 squared, which is 16. That's exactly what we were going to do originally. We would say 4 squared equals x squared plus 6x. But I showed you why. We skipped that. You don't really need to show that because we know the definition of the log, but I was showing it to you to know that the exponent and the log are inverse functions. Okay? So if I have 4 squared, if I take log to the base 4 of that, I will get 2. Okay? They are inverse functions. 4 to the log of 4 is the same of log of 4 to any power. Now it became a quadratic equation. So I say x squared plus 6x. I subtract 16 from both sides. That becomes 0. And now I factor that. I need two numbers whose difference is 6, because that's negative, not positive. So I say difference, not sum. And their product is negative 16. The larger of them would be positive because that's plus 6. Of course, it's 8 and negative 2, right? So you say x plus 8 times x minus 2 equals 0. Meaning x equals negative 8 or x equals 2. We have two answers. These two answers work, but again, in some other problems, they may not work. What do I mean by that? What I mean is, suppose that this wasn't 8, it was backwards. So that was a negative 6x. So they give you the problem x squared minus 6x. That would be positive 8, and that would be negative 2. If you substitute here with negative 2, you get negative 2 squared is positive 4, minus 12 is negative 8. You cannot take the log of a negative number. It doesn't exist. Log of x, x has to be greater than 0. So if I get natural log or log, doesn't matter. So if that number was negative, I say, oh, 8 and negative 2, no, the negative 2 won't work. And I cross it out. I say, doesn't work. If you leave the two answers, you would lose points because you didn't check. But if we check here, it doesn't matter because negative 8 squared is already positive 64. And 64 minus 48 is 16. And log to the base 4 of 16 is 2. We know 4 squared is 16. And the 2, of course, is positive, so you don't need to check it. But if you do, 2 squared is 4, and 6 plus times 2 is 12. 4 plus 12 is also 16. 4 squared equals 16. Here we have two solutions. If that was a negative, I would have excluded x equals negative 2, and I would have a single answer, x equals 8. Do you see why? It's very important to check. Like later when, or I think I did one on like root equations. So if you have a square root of something and then you square both sides to get it as x, and you solve, or if it's square root of x squared plus whatever, and then you square both sides and you get two answers. One of the answers may be negative and you cannot take the square root of a negative answer. You have to check. Why? Because I squared. So I introduced another root that may not be valid. Here, I took the exponent and solved. So maybe by doing that, notice that if this is a negative number, I can take the exponent of that, but I cannot take the log of that. So be careful. You have to check your answers. In this case, both of them worked, but not always. Okay? Thank you very much for your time. If you have any questions or something is not clear, please let me know by dropping me a line in the comments section, and I will get back to you as soon as I can. Otherwise, hope to see you soon. Have a great day.